Systems of equations. Now, some of you just looked at me like I was some sort of weirdo. I'm used to it. It's fine. Because we've already done this, right? We did a whole entire unit on systems of equations, didn't we? Okay? So why are we doing it again? Well, practice. Okay, good. What did you say? Oh, yeah, absolutely. Because what kind of systems did we have before? Just linear, right? We had linear systems before. But now we're right in the middle of quadratics. We need to make sure we understand what's happening if we have a system of equations with a quadratic in it, right? So let's remember, real quick, if we have two lines, if we have a system of equations that are both linear, what are the possibilities? Well, that's one possibility, right? How many solutions does that system have? One, because why? It intersects at one place, right? What's another possibility? They're parallel, so what? Oh, no solution because there is no intersection, right? Okay. Here's another possibility. How many solutions does that system have? Not all of them, right? Infinitely many solutions is what we wrote, right? So what if I add, instead of having two linears, what if I have a linear and a quadratic? What if I have a line and a parabola? How many solutions does that have? Ooh, that's not something we've had before, is it? Two solutions. What if I have a parabola and a line? What other possibilities are there? One solution? Okay, what does that look like? Oh, I don't know what I was drawing. Ignore that part, sorry. So I have a parabola, and you want the line to be like exactly at the bottom like that? So it's just like a tangent? Like geometry. Yeah. Mm-hmm. What if it's just like a vertical line? Isn't that also just one solution? Pretty much any other line that goes through is going to cross it twice, isn't it? Maybe, maybe not. Maybe. We don't have to care about that, right? Okay. So what's another possibility? Parabola and a line. How many solutions there? 0. Doesn't even touch. Okay. What if, dun dun dun, I have two parabolas? What possibilities do we have then? Okay, I wasn't trying to draw Under Armour. I just was drawing two parabolas. But maybe people at Under Armour know something about parabolas. Or maybe they just like the shape. I don't know. Two solutions though, right? Okay. What's another possibility with two parabolas? Can we talk about that in just a second? Okay, keep that in mind. We're just not quite ready for that yet. So one solution? What would one solution look like? Okay, so if they just barely touch like that, that's one solution, isn't it? What about this? Isn't that also one solution? Okay. Could there be no solutions? What would that look like? Completely separated? One would have to open up and one would have to open down though, right? Because otherwise at some point they're going to touch, aren't they? And what about this one? And infinitely many. Okay? Now, you asked me if there could be 4. So maybe I need to be a little more specific with you and tell you we're only talking about functional parabolas today. Only parabolas that open up or down. So now answer your own question. Could there be 4? Tell me what to draw so that we would have 4 intersections with the parabolas that open up or down. This is my favorite. I see people trying to figure it out by drawing stuff. Remember, that's not a functional parabola. They only have to open up or down. Okay? So I love that you're thinking outside the box. I promise I do. I love that. We're just not there yet. We will get there, just not today. Okay? What were you going to say? So I just want 2. But that's a good thought. Maybe there could be more than 2 parabolas, right? Maybe 3 or 4 parabolas. And for sure we could have a whole bunch of solutions, right? So that's the same thing he said. And we're only dealing with parabolas that open up or down today. Now, this is just a quick commercial break because it doesn't relate to what we're doing today, but it's something he said, so I want to make sure that you understand something. Okay? He said, what if we have one that opened up, 2 that opened up, and 2 that opened down? Like that? How many solutions does this have? If there's 4, the solution is where they all intersect. So how many solutions does this have? None, right? Because, yeah, these 2 touch right here and these 2 touch right here, but is there one place where all 4 of them touch? Then there's no solution to this one. Just something to think about. Okay? Any questions? All right, then let's talk about some examples for today. Okay, let's talk about some examples. How do you know how to solve a system of equations? You know 4 ways. Okay, that's one of them. I'll write it down. Matrix. Substitution's 1. Elimination is 1. Yeah, so all that was left was the one I started, right? That's okay, though. Graphing. Those are the 4 ways you know how to solve a system of equations, right? Now, much to your sadness, once we add a quadratic into the mix, it does not. Okay? So let's make sure we know how to graph, substitute, and eliminate. Got it? So graphing. Let's do that first. Y equals negative 3x squared minus 30x minus 71. Y equals negative 3x minus 17. So how do you want to solve this? You want me to get some graph paper out? We can graph a parabola that has a y-intercept of negative 71. I don't want to do that either, right? We could, though, right? We all have the skills to be able to do that, don't we? Okay? Maybe I'll do that if you're not being nice. No, I'm just teasing. I'm not going to punish you with math. Okay? That's what other people have done. I hate that. Let's use our calculator. Okay? Now, I'm going to go ahead and zoom in. You're only going to be able to see the calculator, not the problems, but you have the problems written down in front of you, right? Yes. Okay. While you get your calculator out, would you please show your neighbor your name on the back of your calculator so that your neighbor can verify that it is your calculator? I'm afraid that my 2 that stay over there have accidentally jumped in someone's bag, like they're trying to escape or something, because they're gone. Okay? When I came back from marching contest, they were gone. Okay? So please keep an eye out for them. I would appreciate that. Okay? So what am I going to do? What am I putting in F1? First equation, right? So negative 3x squared minus 30x minus 71. Thank you. Good job. Good job. Everybody have this one in? So, as she correctly pointed out, I want to put another one in, and so I need to press tab. Okay? If the entry line is not already there when you open a graph, then yes, you do need to press tab for sure. Okay? So I'm going to press tab again to put my second equation in there, negative 3x minus 17, and hit graph. Okay? Now, I can tell by looking with my eyeballs how many solutions are there. 2. Because you can see both of them. I can only see one. But I'm also not stupid, right? I know there's another one down here that I just can't see, right? I can go find it. I can change the window, things like that, okay? Do you remember how to let your graph or let your calculator tell you where that intersection is? Is it okay if I remind you? Menu. Analyze. Which one? Oh yeah, intersection, right? Intersection. So this dotted line and a little hand shows up on my screen. Remember, I want to move this hand because what it says down here is lower bound. I want to move this hand to the left-hand side of the first intersection. Doesn't matter where, as long as it's on the left side. I usually try to get mine kind of close-ish, so it's sure what I'm talking about. And I press that middle button. Now it says upper bound, so I need to move it to the right-hand side. And when I move it to the right-hand side, do you see how the point appeared? Now, guys, some people try to do this and pull it all the way over here, thinking it would show you both at the same time. It will not. You have to do them one at a time. Okay? But once it's on the right side of that dot, I press the middle button, and then the point appears. Now, mine's kind of in the middle of everything, so I'm going to click it and drag it over here to the side so we can see it for sure. You see what the answer is? Negative 6, 1. Okay, I know you didn't see what I just did. I just wrote it. I wrote the first answer over here by my problems. Okay, so we have a couple options here of how to figure out where that other intersection is. Okay, but the calculator is kind of nice, right? I don't mean like it's friendly because it's a calculator, right? But it's helpful, okay? Because I know that the intersection is probably like somewhere right here, right? I just can't see. It's just barely off screen. So watch what it does for me. If I press menu, analyze, and intersection again, and I put this where I think it's on the left-hand side. Oh no, I accidentally pressed. Hold on. Menu, analyze, intersection. Now, do you agree with me that that's probably on the left-hand side of the intersection? Okay. I'm going to pull it all the way over here because I think I probably have the intersection in there, but since I can't see it, I'm just kind of guessing. When I hit the upper bound, look what it does for me. It readjusted my window, didn't it? Like, it's helpful. Okay? So now you can see the second point of intersection, negative 3, negative 8, which is why we couldn't see it because our window only went to negative 6, right? So when I zoom back out so you can see my work, see how I already put one of my answers right here? I've got my other answer of negative 3, negative 8, but you know, because I've told you like 84,006 times, and you just accept that now, that an answer without work is no credit, right? And so what should we do to show our work? Absolutely, I should draw the graph. Okay? Am I looking for an exact replica of the graph? Now, we've already done that, right? We've already taken care of that. So is that exact? Well, it's pretty close. It's close-ish, right? One intersection is up here, so negative 6, 1, that makes sense. Negative 3, negative 8, another intersection is down here, that makes sense. What would be even better than to just sketch a graph? tell me how you got those answers. Isn't that just the steps that we took in the calculator? Yeah. Any questions? Are you comfortable solving a system by graphing using the calculator? Okay. Got it? What's our next way that we know how to solve a system? Substitution. So what if this was our system? Y equals x squared minus 1. Negative 7 equals negative x squared minus x. Can we take a quick commercial break? Look back up here real fast. Tell me how you're going to know to do graphing. The first easiest way to know you do graphing is it says do graphing, right? Solve the system by graphing. What's another way you might decide to do graphing if it doesn't tell you? If they're both y equals. Couldn't we easily put that into a graph in the menu analyze intersection? Absolutely. Okay? Well, if we know where the solutions are, right? If we know what it means to solve a system. Substitution. When are we going to know when to do substitution? Number 1, solve by substitution, right? Number 2, what if one of the variables is already solved for? That would be nice, right? Because isn't that what we've got to do with substitution? We've got to solve for a variable and put it into the other equation. Well, this one's already solved for. So why don't we take what we know y is and substitute it into the other equation for y? Boom. Negative 7 equals negative x squared minus x squared minus 1. Now, we've talked about parentheses in here before. Because you're like, when do I know when I have to use parentheses and when do I not? Well, sometimes it's hard to tell, right? If we're adding what we're putting in the parentheses or what we're, like the term, we don't really need parentheses, but sometimes we put them there just because we feel more comfortable. When we're subtracting, do we need parentheses? Oh, yes, right? Because we need to make sure we're subtracting everything in the parentheses, right? Okay? So what am I really distributing into these parentheses? A negative 1, right? Okay. So the next step after this says negative 7 equals negative x squared minus x squared plus 1. Okay. What do I do now? Yeah, for sure. Combine your like terms to solve, right? So negative 7 equals negative 2x squared plus 1. So subtract 1. I know you said subtract 1. Can we take a pause and pretend like you didn't say subtract 1? Why wouldn't we add 7? Because isn't this a quadratic? Don't we always want quadratics to equal 0? No, we don't, do we? Most of the time, right? The 5 ways that you know quadratics, 4 of them we want to equal to 0. Okay? Or y if we're graphing, right? Well, we want everything on one side of the equation. Why do you want to add 1 in this problem? Why do we want all the numbers on one side? Because what's left on the other side? Only an x squared. And if it's only an x squared, there's no x in there at all, how are we going to solve this quadratic? Square roots, right? Square roots. And square roots means we have to have the x squared on one side and all the numbers on the other side, right? So that's why you want to add 1. Maybe you never thought about that in your brain. That's why I try to think out loud for you, okay? So here I have negative 8 equals negative 2x squared. What's left to do? Yep. So 4 equals x squared. Last step. Square root both sides. Think carefully, think carefully, think carefully before you answer this question. What is the square root of 4? Yes! Excellent. Plus or minus 2. Guys, I know your first reaction is to say 2. I get that. It's not wrong. But you got to remember there's something else, right? The negative 2 also. Okay? So what does this mean now? Is this my answer? No, because why? Where's the solution to a system of equations? They're points of intersection, right? So what did we just find? We found x. How many x's are there? So how many solutions are there? There are 2. Okay? Here's what the first one looks like. 2 something. What does the second one look like? Negative 2 something, right? Because aren't these both x? So does it make sense that a 2 is here and a negative 2 is here? Does that make sense? So how do I go about finding the y's? Yeah, we substitute again, right? That's not why it's called substitution, but that's just how we do this part, right? Do you want to use the top equation or the bottom equation? Oh, absolutely we want to use the top, right? The top is already solved for y, and what are we trying to solve for? Y. So y equals, but we just have to do them one at a time, right? So let's do 2. 2 squared minus 1. Does anybody know what 2 squared is? Oh no, that took entirely too long. You scared me for a second. 4 minus 1? 3. So when x is 2, what's y? 3. Let's do the other one. Y equals negative 2 squared minus 1. What is negative 2 squared? 4 minus 1? 3. So when x is negative 2, what's y? 3. Those are my 2 solutions right there. Those are my 2 points of intersection. Do you have any questions about that? Okay. So the last way that you know how to solve a system of equations is elimination. So let's write that answer down. Not answer, problem. Sorry. Elimination. Here's a problem I would like to do with you today. Y equals negative 3x squared minus 30x minus 76, and y equals 2x squared plus 20x plus 44. Okay? Solving a system with elimination implies that we are going to what? Eliminate. We want to try to eliminate one variable, right? Now, before it never mattered, right? I said choose x or y. We always want to choose the easiest, okay? Same rules apply here, x or y, but I promise you there's going to be an easiest. Before it was kind of a toss-up, right? This time, there's definitely going to be an easiest. Because here's the deal. If I choose to eliminate x's, which x's do I have to eliminate? All of them. So would you rather try to eliminate 2, or would you rather try to eliminate 4? Yeah, for sure. Okay? So then my guess is that you want to eliminate the y's? I mean, that's just a guess. Yeah? So how are we going to go about eliminating the y's? What do we need? Same number, opposite sign, right? What's the number so far? 1 and 1. I just needed one that's negative, right? How are we going to go about finding one that's negative? So we're going to multiply one of them by negative 1. Which one do you want to multiply by negative 1? First of all, does it matter? No, it doesn't. Second of all, why would you choose the top one? Yeah, they're already all negatives. Now we're going to change them all to positives, right? Well, except for the y. 3x squared plus 30x plus 76. Now I'm just going to rewrite this bottom one right here so we have them lined up. You okay with that? Now that I have them written down and lined up, what do I have left to do? How do I solve? Yeah, I combine them, right? I combine them. So what's negative y and positive y? 0. What is 3x squared and 2x squared? 5x squared. What is 30x and 20x? 50x. And 76 and 44? 120. I mean, you were close. And you fix it when you realize. You're fine. It's okay. So now what? What kind of equation is this? It's a quadratic. Yeah, it's a quadratic. Notice it has an x squared term and an x term. So can I solve with square roots this time? Nope, I can't. Okay, so I need to do one of the other ones. So do you think I should graph it? Should I factor it? Should I complete the square? Should I use quadratic formula? So the answer is yes for every single one of those, because I can do every single one of those, can't I? Okay, so which one do you choose? First thing, maybe before I make a decision, what do you notice about all these numbers? So should we divide them all by 5? Okay. Now, guys, there was some question yesterday, because sometimes we divided everything by 5, and sometimes we just factored stuff out. Do you know the difference? You know when we can do one and not the other? So here it's a 5, right? I can divide everything by 5, can't I? There was one problem we did yesterday where we factored out a 5x from everything. Can I divide everything by 5x? If I'm dividing by 5x, what if x is 0? Can I divide by 0? No. Lots of explosions and stuff happens when you divide by 0, right? I mean, I don't know because I've never done it, but I've heard it's lots of explosions. Okay? If there's a variable involved, you've got to factor that out. So we bring it to the front and leave it in the front. If it's just a constant like this 5, we can divide it out. Okay? So 0 equals what? X squared. 10x. 24. Whoa. Now what? Now we can make a better informed decision, right? Because my first thought, I don't know about you guys, but my first thought is, can I factor this? Because I know it's pretty quick if I can factor it, right? Do I know two numbers that multiply to be 24 and add to be 10? No, yes I do, don't I? Right? 6 and 4. So x plus 6 and x plus 4. What does zero product property tell me I need to do now? Set them both equal to 0, right? So if I subtract 6 from both sides, I get an x equals negative 6. And if I subtract 4 from both sides, I get x equals negative 4. So what have I just figured out? I have two x values, which means I have 2 points of intersection. What does one of them look like? Yep, negative 6 something. And what's the other one look like? Negative 4 something. Okay? Now, how do I find out the somethings? Yeah, substitution, right? Go back to the beginning. Which one of these would you rather use? Top or bottom? First of all, does it matter? No. Why did I also choose the bottom? All positive, right? God bless you. Y equals 2 times negative 6 squared plus 20 times negative 6 plus 44. God bless you. Negative 6 squared is 36. 36 times 2 is 72 minus 120 plus 44. Now we can let our calculator do this arithmetic for us, can't we? Okay. Negative 4. So when x is negative 6, what is y? Negative 4. And then I just need to do it again with a negative 4, right? Y equals 2 times negative 4 squared plus 20 times negative 4 plus 44. Well, negative 4 squared is 16. 16 times 2 is 32. 32 minus 80 plus 44. Negative 4. So when x is negative 4, y is negative 4. Are there any questions?